One slightly new concept that we are going to use, but what we're doing today is essentially what we've done the last 2 days. The one new thing is parallel lines. They have the exact same slope. So if lines are parallel, they're going to have the same exact slope. So if you look at this kind of example written here, what's the slope of this first line? 3. Yeah, what's the next? Your slope's what's written in front of the x, because it's a y equals mx plus b form. And if you notice, again, it's a little refresher, n represents your slope, the b represents your y-intercept. So the number in front of your x is your slope. This has a slope of 3, and this has a slope of 3. That means these two lines are parallel. So we know what parallel lines say what? They never intersect. That's why they have to have the same slope. They have that same slant, so they're never going to touch. Okay? Their y-intercepts do not matter. Their y-intercepts need to be different, or else it's the same exact line. We don't care about the y-intercepts. We just care about the slope. Yes? Yep. All the time. Perpendicular lines have opposite reciprocal slopes. Meaning, a lot of big words there. Reciprocal means to flip. So if we look at the first slope of this line, it's -1 over 5. If we were to flip that fraction, it would become what? 5 over 1. You just flip it. Okay? So reciprocal means you flip that fraction. Opposite means they have opposite signs. So this is negative. This new sign is going to be what? Positive. And when we reduce this down, 5 over 1 reduces to 5. So if you notice, opposite reciprocals. So these lines are going to be perpendicular. Again, we don't care about the y-intercepts. We just care about the number in front of the x-axis slope. Right? If you want to make a note, opposite reciprocal is flipped fraction and opposite sign. Flip the fraction, change the sign, you got a slope that's perpendicular. Okay. Questions over there?
So, if it's negative and positive before the x, like both of them, one was negative, one was positive before the x, like that.
The fraction also has to be flipped.
Yeah, two scenarios.
It has to be both. The signs have to be opposite, and they also have to be flipped fractions in order for them to be perpendicular.
Okay.
So like if you had something that was like y equals -4x plus 7 and y equals 4x minus 9, those aren't perpendicular because they are flipped fractions.
So it would have to be like negative 1/4 or positive 1/4.
It'd have to be -4 and then positive 1/4 in order for them to be perpendicular. Opposite signs and flipped fractions.
There's the opposite of that up there.
Hmm?
Matter with like is
You could have positive 1/5 and -5. Just they have the opposite sides of each other and then flip fractions. Where the doesn't matter if the first equation is negative or the second. So this first example, we want to figure out which of the following lines is perpendicular to this line. X plus 6y equals 12. Well, again, all we care about is the slope to determine if they're perpendicular. To figure out the slope, we need to take this line and write it in this form. Y equals mx plus b. What do you notice? Which variable is by itself in this form? Y equals mx plus b. The y. So in order to get this in y equals mx plus b form, we have to get the y by itself. Once we get the y by itself, then we know the slope. Okay? How are we going to get the y by itself?
subtract 10x.
Yeah, move the 10x over. The x is first in the equation, so I'm going to keep the x first. So I'm going to rewrite it as -10x plus 12. And then what do we have to do with the 6? To get y by itself. get y by itself. Produce your fractions. What is negative 10 over 6 reduced down to? Negative 5/3. And what is 12 over 6 reduced down to? 2. So there's the equation of this line. This is the same equation. We just rewrote it in a different form. Okay? If we want a line that's perpendicular, what do we have to do with the slope of this line? What do we have to do with the fraction? What do we do up here with this fraction? You flip it. Good. So if we were to flip 5 over 3, it would become what? 3 over 5. So they're flipped. And what do we know about the signs? They're what? Opposite. So this is negative. The slope of this line is going to be positive. So the slope of our new line needs to be 3 over 5. Which one of those equations has a slope of 3 over 5? D. That's our answer. We don't care about our y-intercept. We just care about the slope. So these are flipped versions of each other and opposite signs. So that line's going to be perpendicular. Okay. Parallel lines have the same exact slope. Perpendicular lines are flipped and opposite.
All right, so got it? Again, take away that opposite reciprocals, parallel, are exactly the same. Because that's going to build on what we did yesterday involving this problem here. So we want to determine, based on this, algebraic whether or not A, B, and C, D are parallel, perpendicular, neither. So when we're trying to determine if something's parallel, perpendicular, neither, what are we really looking at? We're looking at what? Just so I know. All right, tell you what. The M, which stands for slope. We are looking at slope. So, look over here, number 2. Do we have the slope? No, we do not have the slope. Is there a way to find the slope? Why, yes, there is, Alexia. Thanks for shaking your head. There is. Does anyone remember that formula to find slope? Okay, back at you, Alexia. y2 minus y1 over x2 minus x1. Again, you're not given that, so please remember that. Because you need to find that, or remember that till you find the slope. All right, great, fantastic. Now, here's a problem that a lot of students tend to make here. They know they had to find the slope of AB, and they had to find the slope of CD. But some of you guys are lazy and don't read directions. Sometimes I do it as well. And here's what a lot of students do. They start labeling x1, y1, x2, y2. Because it looks like it's A, B, and CD. What's the problem with these points, though? They're not in order, okay? And again, it doesn't matter whether you AB or BA, but I definitely have to match up those two letters together. So I'm now going to label B and A. And it doesn't matter what you call X1, Y1, just call them consistently. So let's look at the B and the A, and again, they're right here, in case you want to see where they're at. So when I do that, I'm going to call this X1, Y1, X2, Y2. And we plug it in the formula to find that slope. Let's go do so. Y2 is my first one. Y2 is a negative 7. Always, always, always include that negative behind it right away. It could change out. It might not. But always put that negative there. My Y1 value is a negative 4. We'll go back to that in a second and see what happens. Let's do my X2 value. It's a negative 8. Throw that negative right behind it. And it's going to be a 4. Our next step is always going to be simplifying this. The top one, when I have minus a negative, what always happens? Turns into a positive. Thank you, Leah. Goes to a positive. I don't know if you can do plus plus or just make a plus sign, doesn't matter. And let's simplify that. Negative 7 plus 4 gives me this number is, well, it is negative 3. Thank you, guys. Over. Negative 8 minus 4. Well, it's going to be a negative again. What's 8? 4 together? 12. What do I need to do to all fractions? Simplify. What does this simplify down to? What? 1/4. Positive or negative? positive, because remember, a negative over a negative becomes positive, just like you multiply two negatives. It is 1/4. Now, I just want to stop here for a second. We're going to determine whether this is parallel, perpendicular, or neither. If this was parallel, when I do DC here in a second, if it's parallel, what would be its slope? If it's parallel, what would BC slope be? 1/4, exactly the same. We'll find that out in a second. If it was parallel, what would we expect this slope to be? Or did I say parallel? If it was perpendicular, what would you expect it to be? What? U. Okay, good. Ventriloquist here. It'd be what? 4 over 1 or 4, but what has to happen with that sign? Negative. So it would have to be -4 or 4 over 1. I'll be able to look at it. And then neither, it wouldn't satisfy one of this ones. So let's see what it is. So again, I'm going to go back, make sure I'm doing the right points here. So this is x1, y1. Whoop, that's wrong. x1, y1, x2, y2. And we do the slope formula again. y2 is -5, according to my formula, that's what I need to do. Put that minus right behind it. y1 is 7. Over. Go to my x2 down the bottom. -2 minus 1. And let's solve. Don't have to change anything because I don't have minus negative in there. -5 minus 7 gives me this number. -12 seems like a theme here, huh? Over -2 minus 1. -3. Good. Reduces down to 4. Positive though, right? All right, so let's analyze. Parallel, perpendicular, or neither? Neither. They're flipped. Exactly right. This is a neither problem. This is neither because it is very tempting. You'll see lots of these. It's neither because they are flipped. 1/4 is flipped is 4. 4 over 1. How do you think about it? But they are not opposite. Meaning one is not positive, one is not negative. You have to have one negative, one positive. If they are not, automatically goes into neither. I don't care what it is. As soon as you see one's negative, one's positive, stop right there. It's neither. You can't have two at the same time. They won't work out. Questions with those? Again, nice little review of doing a slope and just analyzing whether it's perpendicular or parallel. Let's try another one here. All right, same kind of thing. A, B, C, D. All right. What do you notice about these points? Yes, you? Okay, ask a question. Great question. What if it tells you what it is? It will tell you A, B, and C, D. So I want to get A and B together, and I want to get C and D together. Now, it doesn't matter if you say A, B, or C, B, or excuse me. It doesn't matter if you say A, B, or B, A. Just label them consistently, and you'll be fine. All right, so we are going to match those up again. But what about these points? What do you know is different about these points, other than there's different numbers? They're kind of in order now, right? So you got to pay attention to that. Because I don't want to go back and think, all right, well, this time it was the first and last one. Now they're both the first two. So let's go ahead, do our same thing, and label them. So I'm going to look at these guys right here, A and B, label my points. X1, Y1, X2, Y2. I need that slope formula. So when I do so, I still have it. Y2 minus Y1 over X2 minus X1. I'm just rewriting it so it's ingrained in your memory so you know what's going on. And I plug it into that formula. So when I do so, I'm going to have my Y2 first, because that's what it tells me to do. So it'd be -6 minus Y1 value is 8 over 4 minus -3 equals that. What is -6 minus 8? It's going to be negative, I'll tell you that. 14 over. What happens to that minus and negative again? Positive. Good. And we know 4 plus 3 is 7. Reduce your fraction. I get this. What? 2. Got 2. -2. Good. Now that one. Again, parallel will be exactly the same. This next one I saw. Perpendicular, opposite reciprocals. and then neither. It's a bunch of different cases for that one. Let's try to see what DC is, or CD. And again, this is one where it doesn't matter what order you do. I'm just going to label them as they are to stay consistent. So x1, y1, x2, y2, and let's go. Y2 is -7 minus y1 is 5 over 4 minus -2. I should be well versed at this. -7 minus 5 is -12. Minus negative, positive once again. 4 plus 2 is what's this reduced to? What? -2? What do you notice about these slopes? What do we call if they're the same? What name do we give Aaron? Parallel. So parallel. Parallel. Very good. Or the symbol for a refresher, just kind of looks like that 11. Two lines side by side. Questions with that one? Let's dive in a little deeper. Now we're going to apply what we know today to what we've been doing yesterday. So flip it over. We need to write an equation now. Not only are we finding slope like we've done in the past, but now we're going to write an equation. Look at this equation. So we want to write an equation for a line containing the point 1, 7. That's upside down t. What's that symbol? Oh, my bad. Perpendicular to the line y equals -2x minus 7,390. Get your calculators ready. It's going to be a big one. All right. Get it out, ready to go. So here's what we need to do. I can start thinking about this. I need to write an equation. The formula of the equation we all should know is y equals mx plus b. Again, that's another one you have to memorize, but hopefully you guys have that memorized by now. I only need two parts for this formula. Those two parts are this. That's going to be in there, but I'm saying back to our line. You're right. You're exactly right. But when I do this, I need what? I need the m, and I need what other letter? B to write my formula. All right, great. So can I find a slope given another line? Can I figure out where the slope's at? Can I? I'm looking up here. Can I figure out the slope? Yeah, the slope sits in front of the x. So I can't do that. But I'm not going to be able to find the b. I'll have to solve for that. But this thing right here is key. That's important right there. That's perpendicular. Because I need to look at this slope, but I need to make it perpendicular. So what do I have to do to this slope to make it perpendicular? Got the same person's answer the same. Derek! Turn it to a positive. Step 1. I like it. So my new slope will be positive. Got it. I made it positive. Now what else do I do to this? It's after that. I'll make it positive. And one person knows. Everyone's been sitting here for 2 people now. Okay, good. Have that in the record. 2 people know.
One person doesn't.
Yes, you. No, you. You're called on. You're too late. You're going to call you. So I need to, going back here what we talked about, I need to do what to make it? I changed the sign. What else do I need to do?
Looks like the only other thing there is to flip the fraction.
What? You said you didn't know. That's lying. It's not nice to lie to people like that. So when I have a 2, and I want to flip the fraction, it now becomes a, if I flip 2, it becomes 1 over 2. So my opposite reciprocal, that's good guess. It is 1 over 2. That's a slope that is perpendicular to that slope. So, and Alexi was already hinting on this because this is what we did yesterday. We have our slope, but now we need to find the equation. We're given a point. So we are going to have to use this point, the x and the y, and plug it into our y equals mx plus b formula, because we need to find that b. Some people ask, what's with that 7,390? Nothing, just throws you off, you don't need it. That's the equation of that line. We're just trying to find a different line. So we're going to take our m, we're going to take these points, and we're going to plug it into that formula up there. So let's do some. So my new y value is going to be 7. is equal to my slope of 1/2. My x is 1, and I'm finding that b. We know what to solve. This one's a little messy because it got fractions, but no big deal. We'll solve it together. What's 1 times a half? Quick, your calculators. 1/2. All right, good job. Fast calculating skills. Plus b. The last step here. How do I solve this? Don't overthink it. I know it's a fraction. What do? You subtract it. So you minus 1/2 minus 1/2. In fraction form, what's 7 minus 1/2? 6.5, right? So I know when I do this, b is going to be equal to 6 is 1/2. Now when we look at fractions, we don't like fractions to be in mixed numbers like this. So can we turn this into an improper fraction? You remember how to do this?
I was gonna say, it's also equal to 6.5.
It is a decimal, that's good, yeah. And we could do that. I would do that. If I was graphing, I would definitely turn it to 6.5, a little easier to graph. But for the sake of the equation, we're going to turn it into a mixed number. And you guys can do that in calculator, however you want to do it. If you don't remember, you take this number, multiply by the bottom number, then add the remainder on top. So it's 6 times 2. Add 1. 13. So b really is equal to 13 over 2. So, guess what? Or 6.5, everyone think about it. I now have my slope, I now have my b, we have the pieces, let's put them together. So I'm going to say y equals, my m is what? What's the new slope? 1/2. Got that x there. What's that b I established? 13 over 2. It's plus 13 over 2. And you are done. There's an equation of a line that is perpendicular to that line right there and passes through that point 1,7. Questions? All right. Let's do one. We did one that is perpendicular upside down t. Let's do one that is 11. That's not 11 though. Write equation for a line containing the point 2, 0 and is, what's that? Parallel to y minus x plus 5. Y equals minus x plus 5. All right. The same exact process. What do I know about parallel slopes? They are what? Stick? They're the same. So what is going to be my slope of this equation? It is, oh, here's a good one. What is the slope of this one? Yes, you, Emmett. Thanks for raising your hand. It is a what? I like the negative. That's fantastic. What is sitting in front of that x, though? It's not there, but it's there. 1. It is a -1. So that's the slope I need. Got my slope? Let's go back and plug it in. Again, for your refresher, so this is very deep in your memory banks, y equals mx plus b. You guys are going to be having nightmares about this equation, if you haven't already. So, what do I need to do? I'm going to take these points, take that slope, plug it into that formula. X and y, and let's go. So my y value is 0, is equal to my m value of -1, because I want the slopes to be parallel, times my x value of 2, plus b. Grab the calculators. 1 times 2 is this number. 1 times 2 is? Negative, sorry, it's -1, you're right. So it turns into a -2, plus b. One last step. Almost fell asleep up here. You guys are so excited. Okay. Yes, Derek. Thank you, USA. He says add 2, good. It's a freebie, guys. You want to be a part of the class. It's a freebie, too. 2. Hey, guess what? We got the 2 bits of information we need. Let's plug them in together. So I now know that the y equals, my slope didn't change because it's parallel, -1. Include that x. What I find my y-intercept to be? 2 plus 2. Got it. Question of that. The process remains the same. All right. What if it's written differently? What if there are graphs that you have to analyze? Oh no, if only.
In 6, that's what we're going to do. We're going to draw equations of a line that are parallel and perpendicular to that given line. It's literally the same exact steps of what we just did. You just have to find the slope of this line. So what we want to do is draw a line first that's parallel to S, this line right here, and passes through this point 2, 4. Okay? Well, we have to figure out the slope of S to figure out a line that's parallel to it. How are we going to find the slope? Rise over right, you just count. So you didn't give you any distinct points on the line, so you just kind of have to pick your own. I'm going to pick this one right here, and then find another nice intersection point, one that intersects with the grid. Okay? You could pick any point that intersected with the grid. You could have picked this one, you could have picked this one, any of those would have worked. Something like this would not, because it's kind of floating in no man's land. It's not on an intersection point of the grid. So something like that would not be a good one. Don't pick that one. And then just count up and over. How far did we go up? We went up 1, and how far did we go over? 2, but we went to the left, so it's going to be negative. And you can rewrite that as just like negative 1/2. You leave it the 2 in the bottom negative, it's not the end of the world. So that's the slope of S. If we want to draw a line that's parallel to S, what do we know about that line's slope? It's parallel. The same. So if the slope of x is negative 1/2, the slope of our new line is also going to be what? Negative 1/2. Okay, we know that. And in order to graph a line, we need to figure out the equation. And we always write it in y equals mx plus b form. So just like what you did in the previous problem, you're going to take your slope, plug it in for m. We want it pass through this point, so we take this point, plug it in for x and y. Just like what you did on the last problem. X, that's y. So 4 goes in for y, negative 1/2 goes in for m, and 2 goes in for x. Okay. We want it to be parallel to s. So find the slope of s. We found the slope is negative 1/2. That means it's going to have the same slope. Take your point, plug it in. And then just solve for b. What's negative 1/2 times 2? Negative 1. Plus b. And to get b by itself, what do we have to do with the negative 1? Add 1. So b ends up equaling what? So that's our b, here's our m. We're going to rewrite the equation of that line. Y is equal to negative 1/2 x plus 5. Exactly like what you did on the last problem, you just had to count the slope of that line. And the steps are exactly the same. So let's graph it. Go back to your Algebra 1 days. To graph this line, where are we starting at? We start at the b, which is 5. So always go up on your y. 1, 2, 3, 4, 5. And then follow your slope, which is just down 1 over 2. And there we go. Look through that point. Down 1 over 2. Down 1 over 2. Keep going so you can't go anymore. If we went down 1 over 2, what other direction can we go? Up 1 over 2. So then these two lines have the same exact slope, so they're never ever going to touch. They have that same slant. So they're never ever going to touch. And then you repeat that same exact process. Not typed in there, but we want a line that is perpendicular to S. we need to figure out the slope of our new line. If it's perpendicular, what do we have to do with the original slope? What do we have to do with the fraction? Flip it. So 1 over 2 becomes what? 2. 2 over 1. And then what happens to the signs? They switch. So if this is negative, this guy's going to become positive. So that's the slope of our new line. And then again, the steps are exactly the same. You plug in, you label your point, x, y. You plug 4 in for y, 2 in for your slope, and then 2 in for x. And solve for b. When we solve for b, 2 times 2 is what? B by itself. 4, so b equals what? 0. Okay, well, again, now write your equation is y is equal to 2x plus 0. You can leave the 0. It's more proper to write it as y equals 2x. If you leave the 0, it's not the end of the world. And then we can go ahead and graph it. Our b is 0. That's where we start at. The b is for beginning. So I'm going to start at 0, which is the origin. And then you just follow your slope. So up 2 over 1. Again, it went through that point. If we went up 2 over 1, what other direction can we go? Down 2 over 1 in the other direction. This line is perpendicular to S and it passes through that point. If these two lines are perpendicular, what kind of angles formed right here? That is a right angle. And that's also a right angle. There you go. And they're parallel. So it's a transversal. So if these guys are the same, these guys are the same. Except from the beginning here. Questions over that? Again, it's pretty much what we did the last couple of days. You just have to maybe adjust your slope before you find the equation. Literally what we did yesterday. You just might have to flip your slope and change the sign. Or keep it the same.